Hi, welcome back to C Programming. I am your Dr. Vasu. Here you can find other interesting subjects as well along with the C Programming. Do subscribe the channel and get alerts. Sharing these programs in the Google Drive, and you can find the link in the description. Okay. Now let's continue with the pointers here. Let's take a simple program, a simple thing to understand the pointer. Already we have seen in the previous one. So here we have taken a variable x and a pointer p1. Okay. And the address of x is assigned to p1. And we are displaying the address of x, that is p1 and x. So if you look at it, the value 100, that is the value of the variable x, is stored in this particular memory location. Its address is this one. It's a big number and it can be positive or negative. And we are not interested in this number, what the digits are and all these things, right? Only this is a address or called the pointer here. So now if you compile this and execute, the value of x is displayed and the address of x is this one. Okay. Suppose if you observe your earlier things, already we have written so many times ampersand the variable name, ampersand x. The same program is taken here. And here, suppose if you observe this scanf, in that we have taken ampersand x many a times. And we haven't focused or thought about what this ampersand and all. Here it is actually. When you enter a value, that value is put in a particular memory location, and that address, in this particular address, we are keeping that value. That is the meaning of it. So here, even if you refer this ampersand x, that ampersand x is nothing but the address of this particular variable called x. Okay, now let's display this one by taking the p1 as well as ampersand x. I want to display what will be the p1, pointer p1, or the address of x like this. Both are same, both mean the same, and they give the same output here, because this p1 is nothing but the address of the variable x, or this x ampersand x is nothing but the address of x. So both are same. Absolutely, there is no difference. So p1 or ampersand x refer to this particular address. Okay. Now, indirection operator. What is this indirection operator is? Suppose you take a particular address and you go there to that particular address. Whatever is there inside, we will be picking it up. Whether you have 100 or 200 or whatever it is, whatever the value it is, we just pick the address. That means we are referring with the help of the address, not the variable or the value of it. So here it is, the accessing the value of it is, the p1 is the pointer, and when you put a star here, it gives the value of this particular address p1. What is whatever the value is stored in this address p1 is represented here by just giving a star, right? So this star is nothing but star p1. That is nothing but it refers to the value here. Okay, the variable's name at value. Now, if you observe this, the output will be same 100. That means when you say p1, it is the address. When you say star p1, it is the value of that particular variable. Okay. Now, coming to this pointer declaration, we will see how it is. Suppose we have taken a variable x. Okay, it is assigned with some value 100. We have taken a pointer p1. In declaring, I have taken the star nearer to p1. Okay, fine. And I have taken another pointer p2. The star is taken away from it, nearer to the t integer, int. There is a gap between star and p. Let's take another pointer here, p3. Here the star is taken as a superscript, not even the regular digit. It is taken as a superscript, and there is a gap between these two also. What will happen? How will they affect the actual display of the carrying the value of the address here? Let us see. P1 is P1, P2, P3, all these three are assigned with the same address of X. Okay. Even though there is a change, there is a difference in declaring, we have assigned the value of same value of X to all three. Let's display them. So here is the address of this variable X, and here let's display the P1, P2, P3. What will be the output? Let's see. So if you see the output here, the X, Y, the X, all the X is same, of course. P1, P2, P3, the address is same. So whether you, in defining the pointer, whether you take the star nearer or away or as a superscript, it is not affecting your declaration, the values of the pointer. But the actual notion is you must be careful, and this is the notion. You take the star nearer to P1. This is the general way of declaring or defining the pointer. Okay, now. So whether P1, P2, P3, whatever the way you declare, all these three refer to this particular address only. Now, coming to this pointers declaration, let's take the three variables here, X, Y, and Z. Three variables are taken. One is an integer, another float, a character, right? Now, we have taken three pointers, P1, P2, P3. Okay, they are declared first. And here, address of X is put assigned to P1, address of Y to P2, address of Z to P2, P3. Now, I want to display the P1, P2, P3. Now, the output will be like this. The output is this. So, value of X, Y, Z are displayed, and pointer P1 addresses are, their respective addresses are displayed. If you observe, they are different. 04 here, 8 here, 3 here. They are different. And let us see the meaning of it is. Why these values, these pointers are having different values. Let us see. We have taken the same output here, and let us represent. Let us see what it is. This is the variable X carrying a value 100. Fine, 100. And its address is this one. Okay, we have a big number, and in the last I am referring to last two digits 04. Okay, the same number, last two digits 04. Let's take another variable, that is we are calling it as P1. Second variable Y, it's carrying this value 7.89, and coming to this address, it is having 08 here. Okay, it is called P2. Another one, Z, carrying a character here, and its address is this 03. 03 is its address. It is P3. We have three addresses which are referring to three different memory locations. And coming to this one, this is referring to a character, only one character, single character. And this is a float, this is an integer. Coming to this one, the inner actual meaning of it is, I'm talking about only, just referring only last three digits. 03, only one byte is allocated to this particular character. Is referring to only this character, because it is a character, it is occupying only 1 byte of memory. Coming to the second one, 4, after 3, it's 4. So 4, 5, 6, 7, 4 bytes of memory is allocated to this integer. Okay. Now, coming to this third one, 8, it starts with 8, 9, 10, 11. 4 bytes of memory is allocated to float Y. Okay. That's how we can see how much memory is actually allocated. That is the actual meaning of it is. So here, depending on the values of these variables, the size of this memory allocation takes place. That you can see. That is a dynamic memory allocation. We have discussed this earlier. depending on the size of these variables, the memory size is allocated. Okay, now coming to this pointer declaration, let's explore further. We have taken the same three variables and now declared this P1, P2, P3, three variables as different way. Earlier we have declared them as integers. Now we are declaring them as integer, float, and character. Because they are carrying different values, we are declaring them as a different way. Now, address of X is assigned to P1, address of Y to P2, address of Z to P3. And if you see this, compile this and complete this program. And if you see this P1, P2, P3, the values are replaced. Output is here, this one. So it shows three different memory locations. So here it is, of course, a big number, 59, 60, 64, right? Let us see what this meaning of it is. Again, because we have declared earlier them as these pointers as integers. Now we have declared them as different integer, float, and character. Will they affect in some way? Let us see. So here the same output I have taken. This is the same X, value X, and its address. This is 60. Okay, 60 here. This is a P1. Y. This is 64. 64 here. And P2. Z. This is 59. This is 59. The same address. This is P3. Now, if you observe, again here, it has taken only 1 byte of memory, that is 59, only one byte. Second, from 60 to 63, 60, 61, 62, 62, 63, 4 bytes of memory, again here for an integer. Again 4 bytes of memory starting from 64, 4 bytes of memory is allocated to a float. So whether you declare them as integers or a float or character differently, it is not going to affect it. We can declare them like that. So here, this is the way of declaring the pointers. Okay. So in continuation of these pointers, we'll see some more, we'll explore further. Hope you had understood this topic very well. If you have any queries or doubts or anything want to discuss, please do comment, like, share, and subscribe. Thank you.